Hello students, in this video I will go through the process of proving angles congruent using angle addition postulate and applying midpoints on a line. Alright, let's take a look. So this is a new postulate that I have not introduced yet, so please take a moment to write this down. And this is very similar to the postulate relating to segments. Here in this case, this is the angle addition postulate, which really just means if we take two angles and add them together, it'll form a larger angle. That's all this is. Or you can think of it as a larger angle is made up of other smaller angles. Of course, there is some differences between congruence versus equality. However, for our purpose in the lesson as well as in this course, we are going to treat congruence and equality as if they're the same things. So, and again, this idea of definition of congruence, this further illustrates my point that if two angles are congruent, then they're equal, or you can think of it as if two angles are equal, then the two angles are therefore deemed to be congruent. This point was illustrated in the last lesson, but I didn't go through an example. But what I will go through an example in this lesson, which is the definition of midpoint, which is a point on a line segment that divides it into two equal parts, or you can think of it as the halfway point of a line segment. Please pause the video for a moment and write down the set of givens as well as what we're trying to prove, as well as the diagram. Draw the diagram and label it. So the G here stands for, the G stands for givens. The G stands for given, whereas the P stands for proof. Okay, so hopefully you guys had the opportunity to write down the givens in this statement of reason chart like I have here. It is important for you to label the diagram, and once you've labeled the diagram, I hope that you guys are able to see that this problem in nature is very similar to the segment addition postulate problems that we've gone through in the previous two lessons. So right now what I've highlighted in pink are the two angles that are congruent. Actually, I'm not going to use a highlighter. I'm going to use a pen instead. So I have these two angles that are congruent using those tick marks there. And my goal is to show that angle ABD is congruent to angle CBE. And how am I going to do that? Well, if you look at this, right, the angle that's sandwiched in between the two, angle CBD, is certainly congruent to itself. If I add that angle to either angle ABC or angle DBE, can you then see why those two angles added together must be the same as ABD and CBE? And therefore, in return, we can then conclude that angle ABD and angle CBE are the same, right? So that's the logic, okay? Pause the video and to really try to digest it for yourself, right? If that is not at all clear, again, you can try to experiment maybe with other letters or other numbers. So let's say if I call this angle N, right? And if ABC has an angle measure of N, then angle DBE is congruent to angle ABC. Therefore, this angle must also be N. And since CBD must be different from either of those two angles, I'm going to call that M instead. Can you see that angle ABD is N plus M, and DBE is also N plus M, and therefore they are the same, right? This is what the problem is asking us to do. It's asking us to prove why those two angles are going to be congruent. Okay, ABD is made up of N plus M, and CBE is made up of, again, N plus M. and therefore they have to be the same. Now, how do you go about doing this in a statement and reason chart? Well, very similar to the way that we did it in with the when we were proving segments congruent. So let's take a look, right? I'm trying to prove ABD congruent to CBE as a strategy. Since I know that ABD is made up of other smaller angles, let's write out the relationship. I know that ABD is equal to ABC plus CBD. I'm sorry. The approach that I had taken, because I wrote out the slides before making the video. So I started with CBD congruent to itself, which is fine, right? I can say reflexive. So the next line, right, I wrote that ABC plus CBD is equal to ABD. And why is that the case? Well, this is true because of angle addition postulate. If you're wondering why I skipped lines, that's because, again, these slides are edited. Originally, I put into place here converting line 1 from congruence to equality. But like I said in the beginning of this video and previous videos, we're treating congruence and equality interchangeably. We're treating them the same ways. So that's why I edited and deleted line 2 and 4. So anyway, ABC plus CBD is equal to ABD. Pause the video to see if you can if you need to digest that, and then we can make similar arguments with angle CBE. CBE is made up of CBD plus DBE, and that's because of, again, angle addition postulate. So looking at this now, right, since I know that in line 1 and line 3, right, if I take lines 1 and line 3, if I add them together, right, won't I end up with, on the left-hand side, ABC plus CBD? And again, if I take lines 1 and 3 and add them together, on the right-hand side, won't I end up with CBD plus DBE? I would, wouldn't I? So that's what I'm going to do next. I'm going to take lines 1 and 3 and add them together. And if I do, I'll end up with this. I have ABC plus CBD is equal to CBD plus DBE. Again, I took lines 1 and 3 and added them together. And in return, I end up with line 7. So again, line 7 is the way it is because I'm adding lines 1 and 3 together. The next step, if you look at this, and I'm going to use a highlighter now, since I know that ABC plus CBD is equivalent to ABD, I can make a substitution. I'm going to use another color. Since I know that CBD plus DBE is equal to CBE, I can make that substitution. Right? So I am substituting lines 5 and 6 into line 7 to have my conclusion that ABD is congruent to CBE. And the reason for this is because I'm substituting these lines 5 and 6 into line 7. I hope that you guys can make the connection that this problem is very, very, very similar to the previous lesson. And I highly encourage you to pause and go back to the previous lesson and compare for yourself and to break down why or how this problem is similar to the problems that we had gone through in the previous lesson. All right, let's take a look at the next one here. Let's pause the video. Let's copy down the diagram. Let's also write down the givens and place them in the statement of reason chart and mark up the diagram. Hopefully you guys had some time to do this. So let's take a look. So I know that ELZ is congruent to ILA. So I'm going to use my pen now. So ELZ, which is this guy here, is congruent to ILA, which is this guy right there. My goal is to show that this smaller angle is congruent to this smaller angle. I have an angle in between. So again, I hope you guys can see that this problem is actually really similar to the second problem in the last lesson. We're trying to show that these smaller angles are going to be congruent to one another. So how are we going to do that? So again, same strategy, right? So I know that ELI, or actually ELZ rather, right, is made up of ELI plus ILZ. And that is because of angle addition postulate. And I can make a similar argument with the right-hand side of statement number 1. I know what ILA is made up of. ILA is made up of ILZ plus ZLA. And again, because of the same reason. This is because of angle addition postulate. Since I know that ELZ and ILA is made up of those parts, and I know that ELZ and ILA are congruent, I can then compare those two, or not compare, I can then relate lines 1, 3, and 4 together in one statement, right? I can say ELI plus ILZ, and I'm going to use a highlighter for this. I can say that ELI plus ILZ, right? Which is equal to ELZ. It's the same thing as this guy. So I can make that substitution there. And I'm going to use another color. I can make the same kind of argument for this sum and replace that for ILA. So if I do that, line 5, I can say, oh, well, really, ELI plus ILZ is equal to ILZ plus ZLA. And the reason is I'm taking lines 3 and 4 and substituting into line 1. And I'm almost there, and I'm in the home stretch, because if you look at this, right, our goal is to show that ELI is congruent to ZLA, and I certainly have something very, very, very close to that in line 5. The difference is I have ILZ on both left and right-hand side now, right? I need to get rid of that. So what I need to say then is ILZ is congruent to ILZ. And this is because of reflexive. I can then subtract lines 5 and 6 together. And if I do, I'll end up with ELI is equal to ZLA. And that's because I am subtracting lines 5 and 6. This should say line 6. My apologies. And that's the conclusion to this problem. All right. Okay, so pause the video once again, draw the diagram for yourself, and place in the statement and reason chart the various givens like I have here. So hopefully you guys had some time to think about this. Here we're utilizing the one other definition, which is that E is the midpoint of GO. So how are we going to do this? If I know that E is the midpoint of GO, so therefore I have these two segments are going to be have the same number of tick marks. Since I know that EO is congruent to OM and EO has one tick mark, then therefore OM therefore has to have one tick mark as well. So you can see clearly that GE and OM have the same number of tick marks. We're not trying to prove that GE is congruent to OM. We're trying to prove that GO is congruent to EM. So we'll definitely need to use segment addition postulate and things of that nature, okay? But we'll certainly also need to use the definition of the midpoint. So let's take a look. So now I know that GE is congruent to EO. That's because of the definition of midpoint. And since GE is congruent to EO, and I know that EO is congruent to OM, I'm sorry, GE is congruent to EO, and I know that EO is congruent to OM, I can then add lines 3 and 4 together to make GE plus EO is equal to EO plus OM. Why is that important? Well, that's because I'm trying to show that GO and EM are the same, right? So what do you think the next logical statement would be? I need to show that GE and EO is made up of GO, and I also need to show that EO and OM is made up of EM, right? So I'm going to need to use segment addition postulate here. And that's because of GE plus, and for that reason, we can then make the statement that GE plus EO is equal to GO, and EO plus OM is equal to EM. I want to use a highlighter to highlight this now. Since I know that GE plus EO is equal to GO, I can make that substitution. And in blue, since I know that EO plus OM is equal to EM, I can again make that substitution. And that's pretty much it. That's the end of the proof right there. So line 10, I can say that GO is congruent to, left out the congruent symbol there. GO is congruent to EM. And the reason for that is because of substitution between lines 8, 9, and 7.